single movable pulley. Single means it is a one pulley, and movable means its axis of rotation is moving. Where is axis of rotation? Here we have a axis of rotation. So single movable pulley means the pulley whose axis of rotation is movable. Now we have to calculate the mechanical advantage of this pulley. For calculating the mechanical advantage, we have to apply some effort here. Okay, so when you are applying the effort, a string gets stretched, means a tension is produced in a string, and you have to remember that one string is having a common tension, same tension throughout the string. So here we have a T tension and here we have a T tension, and this is a block which is actually a load for this machine. Now we have to see the here derivation. Now just take a free body diagram. Free body diagram means we have to cut the portion of the machine and check the number of forces acting. So if you will see this portion, here two tensions are applying in the upward direction and load is acting in the downward direction. So two tensions are acting in the upward direction and load is acting in the downward direction. So here we got 2 times tension is equals to load. This is our first equation. Now we have to see the second equation. Carefully see, when effort is applying in the upward direction, for the effort tension direction is downward. But here you will get confused. Why? Because at the lower point, at this point, I have made tension in the upward direction. Now I am making a tension in the downward direction. Now carefully see, for this pulley, load is acting in the downward direction. For this load, tension is produced in the upward direction. But if you will see this portion, at this portion, effort is applying in the upward direction, and for the effort, tension is applying in the downward direction. So if we will balance the forces, effort is equals to tension. Now we have to see the mechanical advantage as load upon effort. So load value we got it as 2 times tension, and effort value we have calculated as tension. So cancel it out, we got mechanical advantage as 2. So mechanical advantage from this figure we have calculated is 2. Now we have to calculate the velocity ratio. For the velocity ratio we have displacement of effort over displacement of load. So here you are applying the effort, so this is the displacement of effort. Okay, and when you are applying the force, whole string will move in the upward direction, so load will also move in the upward direction. This is the displacement of load. Here you have to carefully one thing, that when this displacement of effort move upward by a distance d, this string is moved by a distance d by 2 and this string is moved a distance d by 2, means both distance half and half. From both side, half and half string is moving to completing the d displacement. It means that when half and half string is only moving, so load is only moving by d by 2. This is actually an experiment, but here you have to see like this, that when effort is moving in the upward direction with displacement d, then the load is only moving half of the value. So displacement of effort we have d and displacement of load we have half of the displacement of effort, that is d by 2. So here denominator of denominator become numerator, so 2 times d upon d. So here we got velocity ratio as 2. Mechanical advantage we already calculated as 2. Velocity ratio we have calculated as 2. So when velocity ratio and mechanical advantage is 2, so this movable pulley, single movable pulley, act like a force multiplier, because we know that when mechanical advantage or velocity ratio value is greater than 1, that machine is act like a force multiplier. Force multiplier means what? Here if you want to raise the load of 50 kgf, you have to apply only the force of 25 kgf. So here your half of the force is saved, half of the effort is saved. This is called as a force multiplier. But there is one problem with this pulley. Can you tell me which problem it is? So this problem is that the here effort we have to apply in the upward direction. Upward direction is convenient for us or inconvenient for us? Applying a force in the upward direction is inconvenient for us. So this single movable pulley is inconvenient for a human. So how we will make this single movable pulley from inconvenient to convenient? But we want the same mechanical advantage and velocity ratio. So this we can done by the way to change the direction of effort. How we can change the direction of effort? By attaching a single fixed pulley here. Now you will attach a single fixed pulley here, so the direction of the effort we can change easily. So here this is the effort point, this is again tension and tension is produced. Same thing, this pulley act as a movable pulley whose mechanical advantage is 2 and velocity ratio is 2, and this pulley act like a single fixed pulley whose mechanical advantage is 1 and velocity ratio is 1. This pulleys act as a force multiplier and this pulleys act as a change in the direction of effort to a convenient point. Clear?